Hi, welcome back to educator.com. Today we're going to talk about the 5-number summary and Boxplots. So now that you know a little bit about variability, now we could talk about the 5-number summary. And the Boxplot is going to be a way of just visualizing that 5-number summary just really quickly. And then we're going to talk about how to determine outliers, and we're going to be using conditional formatting in Excel. And finally, we're just going to talk about modified boxplots, which are going to be boxplots where we exclude the outliers already. All right, so there's really 2 ways to summarize a distribution. We've been talking about one way so far, where we talk about shape, center, and spread. And usually when we talk about shape, center, and spread, we often use as a measure of center mean. Right? So mean is what we really sometimes mean by center. It could be median, but a lot of times people use mean. And when we use spread, we often mean standard deviation rather than other pairs such as median and interquartile range, right? That's sort of where the 5-number summary comes in. The 5-number summary is a way of using the median and the interquartile range more as our measure of exactly as a summary of how our distribution looks. And so the 5 numbers are numbers you already know. The minimum value, the Q1, the border of the first quartile, the median, which is actually Q2, right? The median is also Q2 in that it divides the entire distribution in half, so 2 quartiles on one side, 2 quartiles on the other side. Also Q3, the third border, and then the maximum value, the highest value in your distribution. This 5-number summary is often used with skewed distributions. So let me just show you visually what this looks like. So let's say we have a whole bunch of just different data points. And here's our maximum value. I'll just put in a few more. So even. All right. So here's our distribution so far. Now, the 5-number summary would basically say the minimum value is important, the maximum value is important, whatever the value in the middle is, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so about 6 or 7. So let's say something like that. The median, right? And then Q1 and Q3, which would be dividing sort of this by half, right? So around there. And also dividing this by half, which would be right there, right? So here's min, Q1, Q2, also the median, Q3, and also maximum, right? And so in that way, we get a 5-number summary. We may not know all the little dots in our distribution, but we have a very general idea of it. So now we're going to talk about a way to just visualize that 5-number summary just really quickly. It's going to be called a box plot. It's also called a box and whiskers plot. It's called box and whiskers because oftentimes there's a box, right? It could also be on its side, like this, with whiskers on it, right? And oftentimes this box is split up somewhere in between, not necessarily just in the middle, but just somewhere like that, right? This box is often aligned with an axis of values of your variable, right? And then your Q1 is on the low end, right? So Q1 is on the low end. Q3 is on the high end. Those are the sort of boundaries of that box. The line in the middle is the median. And the whiskers end at the minimum value and the maximum value. Okay? So that's how you decipher a box plot. Now, it could also be on its side like this, right? And in this case, the values would go like this. And once again, you would have Q1, Q3, the median, the minimum, and the maximum, right? And so it sort of doesn't matter whether it's on this axis or this axis, but what you do have to know is the box should be in alignment with the values, right? All right, so let's do an example box plot here just by hand, right? Here's an example set. We can easily see what the minimum and the maximum is, so we already know that. Let's find out what the median is. So the median should be right here, so that should be 30, right? Because what I'm going to do is add 28 and 32 and divide by 2. Just find the average of those two numbers, and that's 30. And visually, I just think of it as what's in the middle of 28 and 32. And then let's find Q1 and Q3. So what's in between here and here? That's 20. Wait. Oh, it should be, actually, I miscounted. Let's see. All right, so we count the 18 as the border, the 30 as the border, so each side gets sort of 2. So the Q1 is right in here, so that should be 22. And here, 30 is the border, 55, so it should be right here. Here's Q3. And that should be about 36.5. Is that right? About 1.5 from there, 1.5 from there. Okay. So there we go. We have our 5 numbers. Now we just need to plot them. I'm going to put it on a horizontal axis, just because I have the room for it. And I know that 18 will be on one side of it and 55 will be on the other side of it. So here I'll put my values. We could pretend this stands for age, then I would label it age, right? And let's see, maybe I'll start from 0, right? And sort of divide this up into tens, right? So 10, 20, 30, 40, 50, 60. Great. So let's start plotting our box and whiskers. What I like to start to do is just put dots there and then draw in the box and whiskers. So here I'd put in a dot where one of my whiskers is going to end. And here's the other end of that. And Q1 is right here about. 30 is right here, the median, and 36.5 is about right here. All right, and so now I know where my boundaries are, I could just draw my box and whiskers. And to help myself, I might just write down where Q1 and Q3 is, because that's going to help me draw my box. And here's my median, right? Here's my minimum whisker. Here's my maximum whisker. So this would be a box and whisker plot or a box plot for this data set that we have right here. Now let's talk about making box plots in Excel. In Excel, it's not a great program for using box plots. If you have Stata or SPSS or other statistics programs, those are probably better options. But for some of you, you may want to make a box plot on Excel. So I'm going to show you 2 ways of doing it. One method is by using stocks. This is a stocks chart, and so it's not originally designed for plotting median, Q1, Q3, min and max. It's actually for stock prices and opening and closing prices, right? But we're sort of going to piggyback on it in order to create our box plots. The trouble with that one is that it does not allow you to show median. Right? So this sort of ends up being a 4-number summary. No median. The other option is by using stacked columns. So in this option, you can show the median, but it takes a little more fiddling with it and sort of tricking Excel into showing you something that looks like a Boxplot. All right, so let's get started. Go ahead and download the Excel file, and you'll see that there's a whole bunch of different sheets that have already put in for you. Some of them, the ones that start with A and S, are already pre-answered, so they already have the graphs and everything in there. But you could also follow along. If you go to height, stock, this is where we're going to plot height on a stock chart. All right. So the nice thing about Boxplots is that you could have several Boxplots on one chart, one visualization. So that's what's nice about being able to compare across a couple of 5-number summaries, right? So let's go ahead and find the critical numbers we need for male height and female height. So the thing about stock charts is that they need you to put in their numbers in a particular order. And this is the order you need. You need Q1, the max, the min, and Q3. This order is really hard for me to remember. I always just am like, what? Because it's very arbitrary, but it's because we're sort of piggybacking off of stocks. It's not originally meant for this use. So now let's find the boundary of the quartile, of the first quartile. So in order to do that, Excel has a nice little function for us called quartile. And here's what you have to put into quartile. The input that it receives is the array or your data set, as well as which quartile you would like. In Excel, the first quartile is number 1, right? So you would put in your data, comma, 1. So let's go ahead and do that. Go to data, go all the way up to height. There's male height. I've colored it in blue. Go ahead and select that data. And then I'm going to put in a comma, 1, close parenthesis. And let's look at what we have here. We have this data, comma, 1. Now let's lock that data in place because we don't need that to move anytime soon. I'm going to hit enter. So that's for Q1. In order to find the median, it would be Q2 or median. In order to find the boundary for Q3, it would just be the same thing with a 3. So let's go ahead, copy and paste that function into my Q3 slot. All I have to do is change which quartile that I want it to spit back at me. And so there I have my first and third quartiles. The nice thing about this quartile function is that it could also find you the minimum and maximum values because it considers the minimum value quartile number 0 and it considers the maximum value quartile 4. You could also use the functions min and max, but let's go ahead and use quartile. Makes it easier. I could just copy and paste all of that in there. I'm going to double click on that max one and put in a 4. And I'm going to double click on the min quartile and put in 0. There we go. We now have quartile 1, the max, the min, and quartile 3. Now, let's find the female quartile 1. So quartile, and let's go ahead and find our data, which has now been colored in pink. I'm going to put in a comma, the number 1, and close my parenthesis. Let's see what we have here. If you double click on it, we have our data and quartile 1. And I'm just going to lock that data in place so I could easily copy and paste that all the way down. So I'm going to copy and paste it all the way down. Let's change it for our max value. For our max value, we need quartile number 4. For our min value, we need quartile number 0. And for quartile 3, we need quartile 3. All right. So Notice that for females, the max is slightly smaller, the min is slightly smaller, so is Q1 and Q3 from its male counterparts. Now let's go ahead and put in our graph, our box and whisker plot. Go ahead and select the male and female part of this data set too, just because when you do that, Excel will interpret it as you want it to be the labels for your box and whisker plots. Go click on Charts, and if you click on Stock, you'll see something that looks sort of like a box and whisker plot, right? Now, you could go ahead and click on it, but some of you may get an error signal that looks something like this. To create the stock chart, arrange the data on your sheet in this order: opening price, high price, low price, closing price. Use dates or stock names as labels. We've actually done this already. It has the opening price or Q1, high price, max, low price, min, closing price, Q3. Yet, Excel is not recognizing that we've done the right thing. The reason is because Excel is not seeing that we've actually organized our data into columns instead of rows. And so here's one thing you might want to do. It's sort of a fudge. Just go ahead and pick, for instance, column, right? Just pick any old one, right? And you'll see that Excel is treating each row as if it's a data set, right? What we want to tell Excel is stop doing that. Instead, organize it instead this way, right? So that it's grouping them into columns. All right, so I'm going to move this formatting palette out of the way. And now, if we go back to stock and click on stocks, it should recognize it. I know, it's not elegant, but that's the way Excel is sometimes. You have to force it to do what you want. So I'm going to delete these series because right now it's actually treating each of these 4 rows as a series. But we don't really need that information. We don't need to know how they go across. We just need to know how they go up and down. So I'm just going to change my formatting here so you could see it a little more clearly. White might be a little bit tough to see. So you feel free to pick any color you want. All right, so here is our box plot, our classic box plot. You'll see that our values are sort of clustered around this end. And so one thing I might want to do is modify my y-axis so that I could sort of stretch out the values that are important to us. And the way I'll do that is go to Scale, and I'm going to put my minimum value as 50 instead of 0. And when you do that, it'll sort of stretch this part out from 50 to 80 instead of from 0 to 80. All right, and now we could see our box plot. Here's our minimum value for males, which is around the low 60s, 62. The maximum value, which is 75. Q1, which starts at 67. And Q3, which ends at 71. Here's the important thing about a box plot. So far, before in frequency distributions, we almost always had the values on the bottom. So height would be on the bottom. But now, height in inches is actually shown on the y-axis. And so, because that's an important distinction, I'm actually going to label my vertical axis to say height. Oops. Height. Okay, there we go. In inches. All right. Now we could remember, this is where height is. notice that frequency isn't really shown here. We don't exactly know how many people have a height of 70 or 75, or if any do, right? We only know that those are the boundaries. But there is one thing we do know. We know that these are split up into quartiles. So this represents a quartile from 0 to 1. This represents a quartile as well, from the border from quartile 3 to the end, right? So about 25% of our participants have heights in this range. Another 25% have heights in this range. So using our wonderful powers of deduction, how many people are in this range? 50%. If we had a median line, we would also know where the other two quartiles break up. But unfortunately, in this kind of formatting with the stock plots, they don't show you median. All right. In order to see the median, because you can see it's quite an important number sometimes, let's go ahead and use the stacked columns option. So go ahead and click on height stacked column. And here, I've set it up so that now it's in a format that might make more sense to you and me. Something like min, Q1, median, Q3, maximum, right? So that's an order that makes more sense to me. Or you could order it the opposite way, max, Q3, median, so on and so forth. The reason I've done that is because it's going to make it a little bit easier for us to create our box plot if it's in order. So let's go ahead and find our quartiles. Quartile. And let's find our data, put that in for males. And then a comma and 0, because we're starting with 0. And end parenthesis, enter. All right, so notice that this isn't anything new, but instead of putting in 0, here's what I'm going to do now. I'm actually going to click on this 0. Because this way, the more I make things into formulas, the more I can just cut and paste and not worry about things. The nice thing about clicking on this 0 is that this is because I haven't put any dollar signs around it, it's a relative reference. And so if I cut and paste this down one, it'll cut and paste this one down one as well, right? So it'll refer to the next one down. But I don't want my data to move down, right? So let's go ahead and lock that in place and hit enter. And now once I have that, I could just drag this down, copying and pasting as we go. And look at that. We have all 5 of our values for our 5-number summary, and we didn't have to do anything. So we could see that they're in order from least to greatest. And so now let's do the same for females. So we have quartile, find our data, let's put in a comma, go back, and click on that 0 right there, and hit the end of the parentheses, enter. And then all I'm going to do is lock my data into place. Sometimes I forget and copy and paste, and it's a small disaster. All right, and then I could just copy and paste that all the way down. So far that part has been easy, right? All right, now here's where it gets a little more complicated in order to create stacked box plots. If you go to charts and go to columns, we're going to be using the stacked column. In order to use stacked column, one thing we'll have to do is find out the distance between each of these things. Because in stacked columns, what it'll do is put the next, put a little box on top of another little box on top of another little box, and each of those boxes represent the distance from the previous box to the next box, right? So we're going to have to change this into distances, right? So I'm just going to put in here distance for males, and distance for females, right? All right, so the first one is the distance from 0. So it's just exactly that. The second one is the distance from this value to this value, so the distance between. Once I have that, I can just copy and paste that all the way down, because this will give us the distance between these two, and here we have the distance between these two. All right. In order to do that for females, all I have to do is copy and paste that over, because Excel is relative. It'll say, do it for the column on the right. All right, so now we have our distances. Because of that, we could just take that and click on column, the stacked column, not the sort of side-by-side columns. Notice that right now, it's putting each row as a column. That's not what we want. We want each column to be a column. So I'm going to tell Excel, in terms of chart data, organize it this way. All right? I'll leave this over on the side. Feel free to use whatever coloring scheme you'd like. Just to keep it consistent, I'm going to go with, let's see, maybe like an orange. Maybe this one's more colorful. Okay, we'll go with the colorful one. All right, here's what we need to do now. This doesn't look like a box and whisker plot yet. In fact, there are no whiskers, right? That's where we're going to have to fudge it a little bit. One thing we're going to have to do is start by getting rid of this block. We don't want to hit delete, because that'll just delete and it will ignore that data. That's not what we want it to do. I want it to look as if these things are floating up here. And so instead, what I'm going to do is tell Excel, color these clear. So I'm just double clicking on this, and it should say fill, and I'm going to say no fill. Ta-da! It's invisible now, right? And in terms of a line, I think there might not be a line. Yeah, so thankfully there's no line. Great. So even though it's actually there, you could sort of find it. You can find it. It's there. It's just invisible, because we don't really need that part. That's just the distance from 0 all the way to our min value. Here, we want this one to be our low whisker. Here's what we do. We ask Excel to also make this one invisible. Then we create, let's do that first. Let's make it invisible. Go to fill, no fill, right? And we're going to use error bars. Error bars usually start at the top of that box, whichever box you're in, right? And because we're at the top of the box, we'd like for a bar just to go through our box entirely. So we'd put a minus error bar, a negative error bar, and we'd ask for it to be 100% of our box. Notice that when I do so, you see this little line here? That's 100% of my box. So this is sort of an Excel cheat. You could hit OK. And ta-da, we have our low-end whisker, right? Great. Now, we don't need to do anything with that. We could leave that, because that is our Q1 to median box. And if you hit the arrow button, the up arrow button, it'll just go to the next box up. This is the box that goes from median to Q3. And this top one as well, this is a box that goes from Q3 to max. We need to click on that, make it invisible, no fill, and we also need to give that an error bar as well. That's 100%. Now, in some of your Excel options, you might be able to get rid of these little feet so that it just looks like little bars. And so in newer versions of Excel, that's the case. That's what I usually do because I think it looks sort of ugly to have the little feet there. But you could see it's not a big deal to have the feet. And now let's change our y-axis so that we could sort of see our box plot a little better. You just hit scale. I just double clicked on it, hit scale, and I'm going to make my minimum value 50. Hit OK. Right? And now I don't want it to say distance males. Instead, I'd like it to just say males. So what I'm going to do is just change this into males and females. And then Excel will do this automatically for me. Finally, it'll label it automatically for me. Finally, what I'm going to do is add a little label to my vertical axis so that I remember that height in inches is being shown here. And so here we could see now that the quartiles here sort of split up quite nicely, but the quartiles here sort of seem to be that there are more people, I mean, these are all equal, they're 25% of our people, but that there's a greater range on the low end than on the higher end. So the range, the spread, is bigger between Q1 and median than the median and Q3, right? So our second quartile is slightly fatter than our third quartile, but our first and last quartiles, first and fourth, those are even bigger than these two. All right, so although that's a bit of a fudge, you could see we could use stacked columns in order to create box plots as well. All right. So that's what I mean by it's slightly idiosyncratic. It's not the best way, but it can be done. Now let's talk about when box plots are actually useful. The pros of box plots is that you could plot a single quantitative variable and you could compare two or more distributions really easily. In fact, box plots are really useful for comparing lots of distributions very quickly because it's a good visualization, it's very compact, you could put it all on one graph, and it's easy to compare the boxes. When distributions have many, many values, too many to show individually, you wouldn't want to use a stem plot or a dot plot. You'd want to use something like a box plot. Also, it's nice when you don't need to see anything more than a 5-number summary. But one of the cons is that you can't see frequency accurately. For instance, you can't see how many people have the height of 72, right? But you can see a frequency within a range. You know that 50% of the people lie in between, Q1 and Q3, and you could see that really easily on a box plot. Now, how do we determine whether we have outliers in our data set? Well, outliers are simply extreme values, but that's a really subjective way of defining it. How do we know how extreme? Who defines extreme, right? Well, we have a rule of thumb in statistics. Typically, we determine outliers by saying that an outlier is 1.5 times the interquartile range from the nearest quartile, right? So what we really mean is the upper limit is the nearest quartile is Q3, and you add 1.5 times the interquartile range, whatever that is, right? So that's sort of the upper limit boundary. The lower limit boundary would be from the Q1 boundary, and because we're going lower, we're subtracting 1.5 times the interquartile range. Sometimes with skewed distributions, where the 5-number summary is really useful, you might not need one of these because one side might not have outliers. Only the other side does. So if it's right skewed, we'd only have an upper limit boundary. If it's left skewed, we might only have a lower limit boundary. So we're going to also learn about how to signal outliers in an Excel data file by using conditional formatting. So go ahead and click on your examples, your example spreadsheet again, Excel file, and let's look at photos. Let's look at photos stock. All right, so photos, if you remember from our previous frequency distribution visualizations, that tends to be a skewed distribution. So it tends to be that photos are skewed to the right, where there are some people who have an extremely high number of photos, but most people are sort of on one end, so on the lower end. So let's determine what the outlier boundaries are for tagged photos. In order to do that, we might want to start off by finding Q1, max, min, and Q3. So let's go ahead and put in quartile and put in our data for tagged photos, which is right here. And then I'm just going to put in a 1, comma 1. Hit enter. So our first quartile is going to be locked in place, or the data is going to be locked in place, but the first quartile can be different. All right, so our first quartile is 53.75, that's the boundary. And I'm just going to copy and paste that all the way down and just change the quartile that we're referencing. We need the max here, so that's 4. We need the min here, which is 0. And we need quartile 3. Notice that quartile 3 is around 250, but the maximum value is 4,686, right? So I'm guessing we have at least a few outliers here. But in order to find out outliers, we need to find out the IQR, the interquartile range. The interquartile range is really easy once you have quartile 3 and quartile 1, because it's simply quartile 3 minus quartile 1, right? And so instead of having max and min, let's modify this. Oh, actually, yes, modify. Let's modify it to be the upper and lower limit. And so instead of a classic box plot, we're going to be looking at a modified box plot. All right. So instead of this max and this min, we're going to be putting in our formulas for the upper and lower limit. Actually, the min value, we probably don't need it, because 13 is probably going to be within the boundary. Like if we made Q1 minus 1.5 times 200, that'll be way lower than our actual minimum value. So we don't actually need to modify that one. Here, let's modify this one though. Here what we do is take our outer boundary plus 1.5 times our interquartile range. Excel knows order of operations, so it'll do the multiplication before it does the addition. So let's hit enter. And notice that our outer boundary is all of a sudden a lot smaller than our maximum value. It's 549.375. Now, it would be nice if we could go back to our data and sort of see really quickly who's in that range and who's not. Who's sort of out of that range? Who are my outliers? So if we go up to the data, what I'm going to show you is now something called conditional formatting. Go ahead and select all the data that we want Excel to look at. What we're going to have Excel do is color these data points if they are outliers. In order to do that, after you select it, go to your menu, which you unfortunately can't see on here, and hit Format. There should be an option that says Conditional Formatting. Go ahead and click on that, and you should get a box that looks something like this. All right. Here we want to say if the cell value is greater than something, then format it differently. So let's see what our outer boundary is again. So if you go to Photos, unfortunately, it won't let you put in a formula unless it's on the same worksheet. But since we're on a different worksheet, we'll just have to put it in manually. So if it's greater than 549.375, right, then format it differently. And so hit Format. And one thing I might want to do is just color it in a different color. And I think I'll put in something like red. Color it in red if it's an outlier. And I'll hit OK. OK again. Ta-da! If you look through this data file, you'll see we already have 2, 3, 4 outliers, 5, 6, 7. So we have about 7 outliers in our data of 100, our sample of 100. And so we know that those 7 or so people aren't going to be included. So in order to do a modified box plot, all we would do is plot these values instead of the max and min. Well, here we keep the min though. So here I'm going to click on, so just select these. And here we're going to use the stock option. Let's see if it'll do it for me on the first try. Unfortunately, no. Gives me this error. So instead, I'm just going to click on something else, just so that I could tell Excel, please organize it differently. And then I'm going to go back to my stock. There we go. I'm going to color this something different. Oh. They're also light. Let's see, maybe that one. Okay. All right, and I'm going to delete the series because it's sort of redundant. Here's our tagged photos, and what we see is there's this this range is a lot bigger. Even though there's the same 25% of people in there as well as in here, that's typically what it looks like for a skewed distribution. A skewed distribution will have a small whisker on one end and a large whisker on the other end. Because even though this has the same number of people as there are in this little whisker down here, they're basically, this one just shows you, oh, there's a wider range that captures that same 25% of the people. So this is a right skewed distribution because the top whisker is bigger than the bottom whisker. All right, and one thing we might want to do is label our vertical axis to show number of photos. Just so that we remember, we're not talking about frequency of people here. All right. Now let's use that same idea. Let's use the same data in order to create it with stacked columns. So go ahead and click on stacked columns. And instead of a classic box plot, we're going to be using a modified box plot. Let's put in our quartiles. Quartile and our data right here. And I go back and put in this column. Let's see what we have. Well, we know we want to lock in this data in place and hit enter. And then I could just drag that down. Now, remember, we want to change this maximum value to be modified. Oops. And in order to do that, we have to find IQR, which is simply Q3 minus Q1. And here I'm just going to delete that and instead put an equal sign, my Q3 plus 1.5 times my IQR, and hit enter. All right. Now let's find the distances between these. The first one, I don't have to do anything with that because it's the distance from 0. The next one, I just subtract C4 from C3, subtract C3 from C4, and then I could copy and paste that all the way down. All right. Now let's plot these distances. I'm going to select all of that, hit charts, go to columns, and choose stacked columns. Unfortunately, it's not stacking them. So here on my toolbar, I'm going to tell it, organize it differently. And I'm going to delete my series here because that's not something I need. All right, now we have to do all that fancy formatting. The first one, we know we just need to make it clear or transparent. The second one, we know we need to make it transparent as well as putting in a negative error bar, minus error bar. 100% of that box. And up here, we also need that minus error bar, 100% of my box with no fill. Hit OK. And here's what we have. We should probably change that distance because it doesn't help to have distance. We should probably put something like tagged photos. And on the side, we will change our vertical axis so that it reads number of photos. So we know that those are our values. And there we go. We have a modified box plot. It's no longer from 0 all the way to 5,000. It's from 0 to about 600. And notice that it's still a skewed distribution. Even when we chop off those crazy outliers, we still have our sort of bigger, or our whisker that's on top that is a lot longer than our whisker that's on the bottom, even though they both indicate the same 25% of our 100-person sample. All right, so I'm just going to minimize all this, get rid of that. All right, so now we know how to create conditional formatting so that we could signal these people are outliers. We're actually not including them in our visualization. And we just went over modified box plots. The classic box plot relies on the max and min, but those are very susceptible to outliers, right? So if you have a couple of crazy outliers, that will drastically change your visualization. The modified box plot just simply use those modified boundaries. That's 1.5 times the IQR. This is really helpful with highly skewed distributions, as we saw with tagged photos. Now let's go on to some examples. So approximately what percentage of values in the data set lie within the box, right? So that box with those whiskers, right? What percentage of the data lie in there? Well, we know that this is 25% of our sample, as well as this is also 25%. And each of these quartiles are also 25%, So we know that what's in here is 50% of our sample. In the lower whisker, 25%, and the upper whisker, 25%. And that's one of the reasons why Boxplots are so useful. They just break up that data really easily into chunks that we could really use. So example 2, how would a boxplot look for a data set that is skewed right? Now remember, in a skewed right distribution, we have a few of these outliers that are very, very great. They're very positive, way far away from, the negative side. So what would a boxplot look like? Well, for a data set that's skewed right, which I'll write in red, skewed right. If we had a boxplot that looked like this, we know that the right side, right whisker would be much longer than the left side, right? And probably also the right box would be longer than the left box. When it's up and down, remember that this side, the top part is the greater side, so it would just be this little picture, but just sort of spun around. So let me make this a little shorter. So here, this is the sort of negative end and positive end. This upper side is longer than the lower side. Now what about those populations that are skewed left? In that case, smaller numbers, there's more outliers on the sort of the smaller end of the continuum. So skewed left. In a side-to-side box, it would be really easy to see because the left side would be longer than the right side. And probably even within the box, you'd have that kind of, the left box being bigger than the right box. But remember, when we draw it up and down, the bottom end this time would be longer than the top end. So here, that's the positive end, that's the negative sort of end. And this side box would also be longer as well, right? So skewed left distributions we know either look like this or like this. Skewed right distributions we know look like one of these. What about approximately normal distributions? Well, when you draw it on its side, you know that it has to be roughly symmetrical because it's approximately normal. So that part is easy. But another thing about normal distributions is that most of the values, 60%, are clustered sort of within that, within a sort of small space, and then within one standard deviation away from the mean on either side. And so we could probably guess that these little tails might actually be a little longer than the actual box. So that's sort of how it'd look. But it's roughly symmetrical, you could see. And it's pretty easy to draw that on its side as well, because it's a roughly symmetrical picture either way, right? Example 3. How can you estimate the IQR from a box plot? Well, the IQR is actually really easy to see on a box plot because whatever the box is, the bottom end of that is Q1 and the top end of that is Q3. That's really your IQR, right? And can you estimate the range? If so, how? Well, the range is actually your minimum and maximum values. So the sort of the length of that entire box and whisker shebang, that would be your range. So interquartile range and range is really easy to see on a box plot. Example 4. Is it possible for a box plot to be missing a whisker? If so, give an example. If not, explain why not. Well, let's think about this. We know that when it's skewed, let's say skewed right, we know that this side's whisker can be very small and this side's whisker can be very long. Now, what would it mean for it not to have a whisker at all? Well, one thing might be that you might have so many values that are exactly the same, so you can't quite split them up into whisker and box. For instance, let me give you an example of a data set that might do so. Let's say it's out of 8 values, 1, 2, 3, 4, 6, 7, 8. I just picked 8 because it's really easy to split into quartiles, right? What if all of the values in both quartile 1 and 2 are exactly the same, right? And then 1, 2, 3, 4, right? Then you couldn't have whiskers because it would be arbitrary why these zeros get whiskers and these zeros get to be in the box. You'd probably put them all on the same box, or this would be a very, very thin box. All right, so that's an example. Obviously, you could do it with the other side as well. So this might be an example of a left skewed distribution that doesn't have a whisker. So something like 4, 4, 4, 3, all right? And then 1, 0, -1, -2, right? So in these kinds of plots, it's hard to say what the interquartile range would be. I mean, not the interquartile one. It would be difficult to arbitrarily say, well, 4 is the boundary for the whisker as well as the box, right? I mean, it can't be both, right? So these are the kinds of distributions that would be missing a whisker. So that's the end of box and whisker plots. Thanks for using educator.com.